Hello, welcome to the next episode of the RX Workshop. Previously, we've talked about how to use schedulers and LINQ and also observables in order to use RX. And today we'll be focusing on how to use the LINQ Join operator with respect to reactive streams. Now, if you haven't caught the previous episodes, you can find them on Channel 9, or you can also find them on MSDN Data Developer Center with the reactive extensions. All right, so let's look at how to use reactive coincidence with RX. So as I said previously, we've talked about observables, LINQ, and schedulers. Today we'll be focusing on the LINQ aspect again, and in particular how to use the join operator, the LINQ join operator with RX. So now imagine that you have an reactive stream. Here we have a number of messages that are being pumped in. We have 0, 1, and 2, the on next message is occurring. But what we want is each of these messages to have duration. Previously in all of our discussions, these events have only been point events. They've occurred at a specific point in time, and there's been no notion of duration or how long the event lasts. Now we want to have these kind of durations. In particular, you can see that you can also have overlapping durations of the on next messages. So what's an example of how this might work? So the mouse is a good example. If you have two buttons on the mouse, the left button and the right button, you can certainly overlap when those buttons are depressed. And so here we have left and right, they overlap in time, but of course left can't overlap a second event with its own thing. And so we have this event stream like this. If you have a third button or a fourth button, you might be able to also model those as well. So this is kind of a basic example of how you might have events with duration. There are many other examples. We'll see another one later today. So how do you express this? Well, with RX, events, again, are point events, but you can express them by using event streams of event streams. In particular, what happens is when the first event occurs, it's the begin event, and it causes a new event, and the type of the event is itself an event stream or an observable of some end value. So there's an outer stream, and whenever an event occurs, it tells you about a new event. And when that stream has a message in it, that means that the duration is now completed. And so you can actually have begin information here, and you can carry end information there.
And for example, when the mouse button goes down, when the mouse button goes up, right?
Yes, exactly. So you could have like the position
Exactly.
in those two different locations when they press it down and let it go. All right, and of course they can also overlap with this model as well, as you see here. So this is kind of the basic idea. Use iObservable of iObservable of t in order to represent events with duration. We also sometimes call these windows. In fact, previously we talked about how to use like group by and buffer and some other examples of windows, and you saw that the result of those operators was iObservable of iObservable of t, and so you can think about those things as being duration-based operators in a very similar way to what we'll see with the joins. So this is also called a window. Now let's look at another example. Suppose we have a store here, and we have a number of customers coming in, and we want to compute when customers are in the store during a certain period of time. For example, when the store is open to when it's closed. So we start off with two different dates here. We have May 5th and May 6th, and each one there's an event when the store opens, and then there's a period of time until it closes. The little green bars at the end are the uncompleted messages, and so it kind of signals when the period of time for which the store is open. Of course, these are not going to be overlapping because you can't really overlap when the store is open. It's the contiguous thing in this example. But there are other examples where that is the case, where you could overlap. And then also we have, when customers are kind of at the store waiting to get in, right? And so we have Mo here who kind of
seems he couldn't get out the first.
couldn't get out yet, so he kind of hides behind the shelves or something. And he kind of leaves here. Then there's Larry and Curly. And so you can compute when they're at the store at the same time as it's opened. And the way you do this is by checking when there's two different event streams here, right? Two event streams of event streams. You compute when the two things coincide. So for example, when this line coincides with this line, that period of time, like this period of time right here, shows that they're actually overlapping, and that's when they're actually coinciding. And the same thing for Larry and for Curly. And of course, Mo actually overlaps with this period and with this period here.
The notion of a join could be the overlap of two timelines.
Exactly.
Yep.
So when we compute that, we see that Mo actually overlaps here, and he starts the second overlap here, then Larry here and Curly here, and that's kind of the join.
Yep.
We flatten it out. There are other joins that actually preserve the overlaps as well, and we'll see that later. So how could you write a LINQ query in order to do this kind of thing? What you could do is you could ask for the event stream of when the store opens, And remember, each one of those events is going to be itself an event stream that will signal sometime in the future when it closes. And in particular, we call this thing the store openings, and then there's a corresponding .close, which is the property, which is an event stream that says when the store will close. There's also person arrives stream, and so we take these two streams, and person arrived, by the way, has a leaves event, so when the person leaves. And so what we can do is we can say, let's take the store openings and the person arrives two streams and compute when the overlaps occur between those things, and then we'll put them into some window here called G. So, and that's what the into G signals what kind of where to put the window of the overlaps. And now we'll say, well, the opening day is here, and then the people that arrive are in G. And now we've actually computed when people are in at the store at the same time that it's open for each day. And so this is an example of how to use the LINQ Join operator in order to compute coincidence in a reactive streams. All right, let's take a look at some examples.
Okay, so let's start by creating again, a simple console application and take a look at all the operators that we've sort of been talking about here. So let's create a console and add a reference to system.reactive to get started. So here we are. So let's first of all take a look at some of the operators that allow us to express some duration, because we will need those duration selectors that actually say how long a stream actually lasts. And if you've actually looked at Rx before, you might have wondered about some of the operators in there, like for example, never. So like never is one of those guys that's used to represent an infinite duration. Say that a person, enters some place but never leaves there for some reason, could actually model that as observable.never, which means the window never closes. So that person's enters event would actually be an observable of never of the leave event, which will of course be some object representing that the user is leaving. Now in a lot of cases you don't even need some specific information to carry with a stream, you just want a signal. So that's something where you can use this special type that we have sitting in Rx as well called unit. So that's basically a stream that signals at no point in time that something happens. You could also do like observable.timer kind of things to basically have some particular duration associated with an event. And you could also map that thing onto unit because it doesn't really carry any information that you care about. So like those units are kind of signal wires in Rx.
Yeah.
So that's one of the things you could actually be using here. Other operators that come in handy here to sort of model duration and time is things like timer, where you can say after a certain specific amount of time, basically fire a particular signal that could signal the end of a stream. So those are some of the operators to
There's also empty as well, if you want to immediately close the duration.
Yep. So empty would be sort of the total opposite of never, in a sense that it immediately tells you the completed message at the point you subscribe. So it's actually a zero duration event. Yep. So we have all of those guys. So now let's take a look at the join operators that we actually have available in Rx. So as we said before, the things you want to look for are those operators that have this interesting use of nested types of iObservable of iObservable, where the outer one actually represents the events, and the inner one actually represents the duration of the events that's associated with the outer event. So like window we've seen before is one of those guys that actually has that particular signature. So you should already be quite familiar with the notion of those nested types. So now let's take a look at how the join operators actually look. So we have two of the join operators called join and group join. We saw one in the slide before. The one that we saw there using into G is actually the group join. It actually exposes the group of the people that were in the room at the same time to the selector function behind it. So you can actually take a look at all the people in the room. So the join and group join operators are the ones that the language actually binds to. So let's take a look at how those things actually work. So if you take a look at the signature here, you have two sequences. You have the left sequence and the right sequence. Like for example, the store together with the people that are two distinct notions, and now you sort of want to join them. So for every of the elements from the left and every of the elements of the right, you need to specify a selector function. And that's actually where the overloads of join differ from the enumerable ones, in a sense that the thing returned from those functions is not some value that you compare using an equality comparer, but it are two values that actually represent the inner streams of the durations. So as you can see over here, the function of the left actually produces a left duration selector. The function of the right produces a right duration observable. And so when those two guys overlap, the function is called with t left and t right during the overlap, producing a result selector that's then projected in the output sequence.
And so just as you said, the key notion here is that we are not doing equality-based joining, but we're doing a join based on when things overlap in time or coincide.
Mm-hmm. Yep. So we could actually, give a very, very simple example here, just an academic example of like selecting like some inner duration selector and seeing like how those things actually pan out. So say that the left sequence is just something that produces values based on time, let's say. And then we'll also have something that produces values based on user input using the console. So let's say the outer one is observable dot, let's use interval to basically produce some messages. It will be kind of regular, of course, in this case, from seconds, say 2 seconds. So we have the left guy that actually produces values every 2 seconds. That's just an observable of long. It doesn't really carry much useful information, but we'll actually map it onto windows of time. So we're sort of building kind of the window operator manually here as well.
That's right. Actually, for those that are kind of like, the theorists out there, they might note that the group join is actually the most powerful of all the window operators that we offer.
Yep.
You can express the rest of them in terms of that one.
It's, just like select many is, the king of LINQ to objects. If you deal with time, like group join is a very powerful guy to look at.
Yes.
Yeah. So let's actually just do our little trick that we did before. Basically creating, read line, a stream of inputs from the user, and we'll actually use it as the right-hand sequence. So we'll say write equals inputs dot to observable. And maybe I want to introduce some more concurrency.
Yeah, new scheduler, new thread there usually works out the best.
So we've discussed, the use of schedulers in previous episodes. So
that's
if
right.
you don't recognize the scheduler, take a look back at that information.
Basically what we're doing is we're given a dedicated thread to read the console.
Yep, exactly. So now that we have left and right, what we need to say is when events actually overlap. So for every left event, which is actually based on the timer, we now need to select an event that basically indicates the duration of that particular tick of the timer. So let's say we're actually projecting that on a constant duration that's actually a certain amount of time. So we'll basically take that long value, as you can see over here, which is coming from the timer, which we don't really care about, and we'll map it onto the duration of the event. So every second I want to create, say, an event of 5 seconds, like a window of 5 seconds. So I can do observable dot timer, and I can basically say time span from seconds 5, which means that we get an event after 5 seconds from the time the window is actually opened. Now we need to do something very similar on the inside. We need to say how long, it takes for a user input to sort of be valid in the system. So we can sort of give it a duration.
Say it's instantaneously invalid.
Exactly. So
it's valid for like the smallest an iota of time.
Yeah. So you want to use empty here?
Yes.
Let's use empty. And of course I need to specify some result here, which is kind of arbitrary in this case.
Can I point out something? So in this case, the left event stream now has events with duration of 5 seconds, but the right stream is actually point events.
Yep, exactly. So so if you look at the window operator, for example, the window operator treats things as such as well, right?
Yes.
You have the time-based operation that's sort of creating those windows of time, and then values, which are point events, are actually being projected into those windows.
Yep.
So we're actually getting darn close to the window operator here. So I don't really care about the empty thing. You have a suggestion here?
Unit looks good.
Exactly. So we have that, and now finally we need to produce a result selector. So the result selector takes in the tick of the timer, which I'm not really very interested in, as well as the string that's actually coming out of what the user actually has written. So
you could use the long as the window number,
Yes, exactly.
And the string as the input, yeah.
Okay, and so what do we like to produce here? Maybe just a string that says that that particular S appears in that particular window.
Yep.
So we'll actually say user wrote, and let's just use string concat for this once, in window I. And you will actually see that some of the things that user is writing appear in multiple windows, of course, because those windows are also overlapping. They start every second, but they last for 5 seconds. So we have this now, which is the result. And the result is an observable string. And so let's actually run this guy. Let's just say result.subscribe console write line to put those things on the screen. And just to make sure that...
Oh, but you have 2 read lines now.
Oh, I have 2 read lines.
So
yes, this
run.
conflicts. Let's just use for each.
Yeah, for each. Yeah, that's it.
Exactly. And see what actually comes out. So at this point, we're already pumping those windows that have a certain duration, but the user hasn't typed anything yet, so we don't see anything appearing on the screen, of course. So as the user types something like, say, hello, you see that hello was projected into those 3 windows that were active at that particular time. If the user types something else, you see that message being projected into different windows. Now, those particular values that we have sitting here do not have any duration whatsoever. So basically, there are point events that coincide with the duration of a particular window. So that's actually the sample that we have running currently.
So maybe what we should do is try to change the sample so that the user input actually has a duration until the next input comes in.
Yeah, so that means like at this point when the cursor is blinking, world would actually appear in all the windows of the time till the user types something new, and then the new input will actually arrive in new windows.
Yep.
So let's take a look at how we can do that. The user actually wrote Ctrl-C in this particular case as well. No, I didn't know that came through console read line, but now we do. So so the way to do that is like, instead of using observable.empty over here, what we really want is we want to use the next event that actually happens in the sequence as the end, the indicator for the end of the duration. So in order to do that, we'll have to use this input sequence multiple times. We'll have to use it once as the input, but we'll also have to use it for the duration selector of the
right-hand side.
Inputs. Yep, yeah. The right-hand side. So when you want to use this sequence multiple times, you have to basically share it so that you don't have multiple subscriptions going on to the same thing, which would actually be kind of nasty in this particular case because you have multiple, while loops going that read console read line, and things get totally non-deterministic in this case.
That would be pretty well.
Yes. So let's actually reuse this sequence by publishing it. And you can use multiple overloads of this guy. You can actually do publish, which gives back a connectable observable. So you can basically take that right-hand side, write a query against it and connect it at a later point, or you can lift everything into a lambda form where you sort of have a safe copy of the inputs that you can use multiple times.
And underneath, the lambda form uses this one.
Yep, exactly. So let's actually lift the whole thing into that, lambda form, which really will mean that, the right-hand side, well, actually, let's do it like this. I'll keep the right-hand side as is, and the result will become using the right-hand side, publish the right-hand side as right underscore, which is an alias, which is now safe to use multiple times. And then we'll use, right underscore in here. At this point, we still have exactly the same query. But now we'll use that right underscore, the safe version of the input, as the duration selector over here as well. So now we should also point out what duration selectors mean. Do they actually indicate the end of the window based on the first event that comes through, or anything else?
Or the completed message.
Or the completed message. So let's actually just paste in right here and see what actually happens. So let's do Ctrl F5 again. Now whenever I type something here, like say hello, you see hello is projected into the windows, and the window is not being closed. It's only when the user types something, an event will happen in the inner window duration selector. So when I type world now, you see that world is actually projected into the next set of windows. So world is now ticking and hello is gone. So we actually closed the window for hello successfully. So the answer is, as soon as the message comes in, actually that indicates the end of the duration.
That's right. And the reason why I went into 6, 7 right away was because they had a long duration.
Yeah, exactly. They have duration of 5 seconds, and they're overlapped there.
Yep. And also, if you can close that window, one more observation here. So for those of you that know about hot and cold observables, basically inside of publish, the right underbar is a hot version inside of the Lambda of write. So that's kind of what's going on. It's basically being shared or being published or broadcast.
It means that, subscribing inside the Lambda doesn't cause additional side effects of bubbling a subscription up to the original source side.
Yep. So sometimes you need to do that kind of thing.
Yep.
And so we take a look at the challenge?
Yeah. You have setting it here?
Yes. Well, I'll have to open it up here.
Yep.
But this challenge is pretty fun. So we've actually shown, and many people have tried the challenge of actually doing drag and drop example.
Yep.
Right. And we've done that. We've actually had a video from an early version of RX about how to do that. You can go look at that for their inspiration. Some of the things are quite dated now in terms of the code. But now what we're going to do is actually have you do the drag and drop example with the LINQ Join operators. So here I have the mouse down, mouse up, and mouse move operators.
Boost the font a little bit.
Yep,
here.
sure enough.
Yep.
What did you do, 150?
150, yep.
Okay, good. So I have the mouse down, mouse up, and mouse move events already called out for you. And there's a query right now which just says never fire any points. And if you can get this to compute a stream of deltas, and this is the point should be deltas, that means how far the X has moved and how far the Y has moved, then the subscribe will just work out. So the only code you should have to change is this code right here. And you can do this using the LINQ Join operator and a few other operators. So that's the challenge, to use LINQ Join. And I personally, and actually our team has thought that this particular solution is the most elegant that we've come across yet. So have fun and try out the challenge and talk to your friends about it. Thanks for watching this.